This question says a small amount of acetonitrile, CH3CN, is dissolved in a large amount of water. Imagine separating this process into 4 stages sketched below. And then it says use these sketches to answer the questions in the table below. In the first box it says the enthalpy of solution, delta H solution, is negative when CH3CN, acetonitrile, dissolves in water. And then we want to put these different stages in order. In order to do that, we need to think about what is going on in this case. First of all, the enthalpy of solution is negative. So that means that this process is exothermic. So energy is released when a solution forms. So that is like this case on this side. So delta H solution is less than 0. So let's see what happens. So first, we have this individual solute and solvent. The solute molecules are close together. In order to form a solution, we need to move these solute molecules away from each other, which Alex calls expanding the solute. This is going to take energy. For all molecules, there's going to be some type of attractive force, whether it's an electrostatic force of a positive ion being attracted to a negative ion, or it's an intermolecular force such as dispersion forces. It's going to take some energy to expand these things. In the second step, we take the solvent, in this case water, and we separate those so there's these holes so that the solute can fill in those holes. This again is going to take energy because again there's going to be some attractive forces no matter what between these solute molecules. We then take this expanded solute and this expanded solvent and we mix them together. And this is always going to release energy. In this case, it releases more energy than what we started with, and we form the solution. So overall, here the delta H is negative, so this would actually feel hot when you dissolved it. In the case over here, this would actually feel cold because the delta H was positive, but it could actually form a solution. Sometimes this delta H is too negative and a solution will not form, but that's not the purpose of this question. So essentially, these are the steps to making a solution. We have those exact same steps over here, they're just not written in a graphical format. So here we have acetonitrile and water interacting with each other. They're pure substances. We then separate the acetonitrile and the water remains unseparated. This requires some energy, so it goes higher up on the enthalpy scale. We then make holes or expand our water from here to here. So now both the acetonitrile and the water are expanded. And then finally, we put these expanded acetonitrile molecules in the hole and energy is released as we form the solution. So it says, use this information to list the stages in order of increasing enthalpy. Well, because this is exothermic, or delta H is negative, the solution, D, has the lowest enthalpy. Because if we look down here, the solution is actually lower in enthalpy than the solute and the solvent. That's what makes delta H of the solution exothermic. If that's not the case, if the solution is higher in energy, then a delta H is positive or endothermic. So D is the lowest in energy. Next, we need to figure out what's happening. The first thing we do is before we do that, the next lowest thing in energy is the individual solvent and solute themselves. And if we look at our diagram, you can see these are relatively close in energy, and this is going to be lower in energy because before we expand anything, this is going to be lower in energy than the expanded system. So the next one is A. Now, the first step is to expand the in this case solute, the acetonitrile. So B is going to be lower in energy than C, which has to be last because it's the only thing left, because in the case of B, only the acetonitrile molecules are separated. In the case of C, both the acetonitrile molecules and the water molecules are separated, so both are separated. This is going to be definitionally higher in enthalpy than when only one is separated. So this is basically the order. If you're doing this for any other question, what you want to first compare is the solute and solvent and the solution based on the delta H. Then whatever the first step is, whatever is expanded first, will be lower in enthalpy than when the second thing is expanded or both are expanded. All right, it says, would heat be absorbed or released if the system moved from stage C to stage D? So looking at this process right here, this is a very unstable situation. We have the solute molecule separated, we have the solvent molecule separated, and then we form a stable situation where we have a solution. Heat will always be released in this case. Even if the process is endothermic, for going from transition from C to D, heat will always be released. And you can see that here on this graph. Here you have both the solute and the solvent expanded, and here you have the solution formed. Heat is released. Even if it's endothermic, if both are expanded, heat is released when the solution forms. It's lower in energy, so heat is released. Finally, it says, what force would oppose or favor the system moving from stage C to stage D? Check all that apply. Well, again, we're looking at stage C to stage D. So we're looking at the intermolecular forces that favor this, right? It favored because we lost a bunch of energy, as we just said here, energy is released. So what is going to favor that? Well, acetonitrile is CH3CN. Water is H2O. So you have a nitrogen that's capable of hydrogen bonding with the water. So the one force that will favor this is the hydrogen bonding force. Remember, if you have the hydrogen bonding force, both of these molecules are also polar, so you have dipole forces, and their molecules, all molecules have dispersion forces. So in that case, all that apply are your hydrogen bonding force, your dipole force, and your dispersion force. Generally speaking, if you have a hydrogen bonding force, you also have a dipole, and you have a dispersion. If you had dipole, you'd also have a dispersion, and if you don't have either of these two, if both molecules are nonpolar, then you would only have the dispersion force.